Okay, so this is the second part. Then after we've created those data and model arrays, then I just load that back in here with this hindcast stats thing, and then I just march through again. And here on one line, we do this really complex tidal analysis with this amazing, T-Tide package, which is a really cool MATLAB package. And this is one of the things that we can't do in Python, so it's like another reason to stay with MATLAB for now. So we do this on the observations, we do it on the model. So now we have these two different things we can use to compare the tides, and so instantly we can see whether, if the model is looking strange, the tides are going to tell you. That's the very first thing you compare. And it's giving me some helpful hints here. And then we do a low-pass filter, which is another custom. Like this is a special filter that we use to filter out the tides. So then this gets rid of the tides, and then we start. Here I did some. I was actually using these other, doing some statistics between the model and the data, but then I used this other thing, StatsV, which is another custom thing, which basically gives us back the mean of the two series, the standard deviation, as well as this complex correlation coefficient. So it's for vector data. So if you have like a correlation, you can have like if the model's doing this and they're going like this and the data's like this, you'll have a complex correlation of 1. They'll have an angle of 15 degrees or 30 degrees or whatever. So anyway, yeah, here's my here's a if 0, and make these plots, make a bunch of plots, okay, of the data, and that's basically it. So then the last one is oops. Hindcast plot. Yeah. And so this one basically just plots up the major and minor axis, plots up does a comparison of the tides, and then here's a base map, it's a mean figures on there, blah blah blah, and then loops through making some plots and then writing some KML. There's like a header, trailer, and then we loop through and just append all these plots, doing again interesting time plot. So I'm using my own plotting stuff to do vectors, and then stack label, doing these own custom thing to do the labeling on each of these panels. Fixed paper 2 to make the plots. When you do the print command, it doesn't change the aspect ratio. It gives you exactly what was on the screen. There's probably a better way of doing that now, I suppose. And then it just creates this KML. So at the end of all this, you end up with some KML and a bunch of pings and a KML. You can put that all together. So here, and then I upload it to our website. So somebody wants to look at the results that comes in, and they open up that KML file that's just sitting out in a shared folder, essentially, and so they come in and they see all these all these observations that have been made in the Gulf of Maine at all these different locations, and when they click one of these things, they see a lot more, and then they get a little table which has some information about the data when it started and stopped, and then if they click one of these things here, actually get the image coming up here in the browser. And normally, if this was a bigger screen, you'd have Google Earth up on one side, and the plots would keep popping up on the other side. So you could look at this particular location. The data and the model are pretty darn different. And so, you can wander around in here and actually get a pretty intuitive first look at how well the model and the data are doing. Some places it looks pretty good, and other places it looks pretty bad. So anyway, that's it for that.